All right, this video is titled Half-Life Calculations. And so we're going to learn how to work with half-lives of radioactive material and be able to find out the amount remaining or the number of half-lives that were required to reduce an amount. Okay, so the notes that you should be looking at are the notes that were posted on Schoology for half-life calculations. There's 3 questions that you're responsible for answering. What is a half-life? How do you predict the amount of remaining as time passes, and what must you remember about the table? And so I'm going to kind of talk through those questions, but I'm going to do that using a little bit larger print. So we've got to start out with what is a half-life. Well, there's a video that I've posted online from another teacher who kind of goes through the idea of half-life. So I'm just going to talk about what we need to know in order to do the half-life calculations. Half-life is the amount of time that is required for half of a sample to decay into a new form, and that's based on what we recently learned about different types of nuclear reactions. We know that atoms can become different types of atoms through types of nuclear decay, and so we want to know, well, how much time does it take for half of the sample to decay into the new form? Remember, the mass isn't being destroyed, it's just being transferred into a different form. Some half-lives are incredibly quick, seconds. Others can be very, very long depending on what type of sample you have. And so when I say very, very long, I mean thousands of years or hundreds of thousands of years. And we're able to use these half-life calculations for a lot of cool things like radioactive carbon dating, and even some like forensic science in knowing how old somebody is based on the types of isotopes in their teeth, all of that based on half-life. So half-life is the amount of time required for half of a sample to decay into a new form. And what we're going to use is we're going to use a calculation table to help us predict the amount remaining as time passes. And so there's 3 things we need in our calculation table: the number of half-lives, the time, and the amount. Now there is an actual equation that you can use to do this, but I found this is kind of the simplest way, and since I'm not here, we're going to go with a simple way. Half-lives, time, and amount. Okay, a couple things we have to remember. Our very first entry is always going to be 0 half-lives because it's going to be our starting time, and 0 time because it's our starting time. And then we're going to put our original amount in our first amount box. And that actually kind of answers our third question. What must we remember about the table? We have to start with half-life of 0 because that's our starting time, no time has passed. Our time is 0 because it's our starting time, no time has passed. And the amount is the original amount because, again, no time has passed. So we can fill in our table, and I just kind of went up to 5, but sometimes you may have to go up to more than that. And so we have 1, 2, 3, 4, 5 as our numbers of half-lives. And then, again, our time starts out as 0, and the amount starts out as the original amount. So how do I fill this in? Well, it depends on the information they give me in the problem. But basically for time, what I'm going to do is each time I'm going to add the half-life that they give me. And then for the amount, each time I'm going to divide my amount by 2. So let's see one of these at work. The first example that I want to talk through says that if I take bismuth 209 and its half-life is 23 days, how much would remain after 115 days if I started out with an 80-gram sample? So again, 0 and 0 for half-life and time, and my original amount was 80 grams. So I know that my half-life is going to be 23 days. So after one half-life, 23 days is going to pass, and so I've added 23 days to that. The amount would be that this would be cut in 2. So 80 divided by 2 would give me 40 grams. So after 23 days, only 40 grams would remain. Well, I have to go all the way up to 115 days. So I'm just going to keep going until I reach 115. So for my second half-life, I'm going to take 23 and I'm going to add 23 to it. So it gives me 46 days. And I'm going to take 40 and I'm going to cut it in half, and that's going to give me 20 grams. Well, I'm not there yet. Keep going. My third half-life. Add 23 to my 46, and I end up with 69 days. And then take my original sample, divide it by 2, giving me 10 grams. I keep going. So my fourth half-life, 69 days plus 23, plus my half-life is going to give me 92 days, and then I would be down to 5 grams. On my fifth half-life, I would be at 115 days because 92 plus the 23 days, if 23 more days passes, I'd be at 115, and I would have 2.5 grams remaining. So how much remains after 115 days? 2.5 grams. So So just remember, I went from 0 and I just added up the number of half-lives. For my time, I added the number of days or hours or seconds. It was 23, so I went from 0 to 23. Add 23 takes me to 46. Add 23 takes me to 69. Add 23 takes me to 92. And then finally, adding 23 took me to 115. For my amount, I divided it by 2. So I started with 80. After the first half-life, I'd be down to 40, then 20, 10, 5, and finally 2.5. So after 115 days, I'd have 2.5 grams remaining. And that's how I use the calculation table. So let's fill in my next example. How much time would elapse to reduce 200 gram sample of YB to 25 grams if the half-life is 3.5 hours? Okay, so I'm going to make my little table. Number of half-lives, the time, and the amount. Okay, remember I always start off at 0 and 0, and the amount that I'm starting with is 200 grams. Okay, so I'm just going to make some rows here. I don't know how many I need, but we'll fill them in as we go. Okay, so I know the half-life is 3.5 hours, and I know I'm going from 200 grams to 25 grams. So I'm going to end at 25 grams. Well, I'm going to have to go and fill this in until I get to 25 grams. So I know that for the amount, I just divide it by 2. So 200 divided by 2 would give me 100. Cut 100 in half gives me 50. Cut 50 in half gives me 25. Okay, so it's going to be 25 grams. Well, how many half-lives is that going to be? 1, 2, 3. 3 half-lives, and my half-life is 3.5 hours. So from 0 to my first half-life would be 3.5 hours. Add 3.5 hours to that would give me 7. Add 3.5 hours to that would give me 10.5. So my first question says, how much time would have to elapse? 10.5 hours. How many half-lives would pass? 3. So it would take 10.5 hours or 3 half-lives to get a 200 gram sample to 25 grams if the half-life was 3.5 hours. Again, 0, 0, my original amount. I had to divide my original amount in half. I had to add the time for each, and then my half-lives increased. Okay, so let's look at my last example here. If I have a sample of compound that changes from 800 grams to 12.5 grams in 18 days. What is the half-life of that sample? Okay, so I just make my half-life table. Number of half-lives, my time, and my amount. Okay, I know I'm starting at 800 grams, and I have to start at 0 and 0. Okay, it's going to take 18 days to get there, and I know that I'm going from 800 to 12.5. So I'm just going to make my table, and I'm going to take 800 down to 12.5. So 800 would go to 400, and then 200, again I'm just dividing it by 2, 100, 50, 25, and 12.5. Okay, so I made it to 12.5. Remember, I just divided those by 2 at each step. Okay, so how many half-lives is that going to be? Well, it's 1, 2, 3, 4, 5, 6. So after 6 half-lives, I'll get to 12.5. And I know that my total amount of time is 18 days. So I'm going to end at 18 days. So I have to figure out how would I get from 0 to 18 in 6 half-lives. Well, I know that 18 divided by 6 is 3. So let me see if that works. So if I put if I went from 3 days, and then that would be 6 days, 9 days, 12 days, 15 days, 18 days. It works. So the amount of time of half-life would be 3 days, because every 3 days my sample would be cut in half. 3 days is my half-life. Okay, so let's just remember a couple of things about our table. A half-life, again, tells us the amount of time required for half of the sample to decay to a new form. We have half-life, time, and amount. Our half-life and our time always start at 0. The amount is our original amount, and then we just fill in our table as need be. Our half-lives just go up, 0, 1, 2, 3, all the way up to wherever we need it to go. Our time, remember, we add the time of our half-life to each box, and for our amount, we have to divide the amount we have in the previous box by 2 in order to work backward. At this point, you should be able to work on your half-life calculation worksheet.